This is Hitoshi from KEM Japan. So today I'd like to have the kind of the presentation about the Karl Fischer to measure the moisture of the sample by using this presentation slide. Okay, so this is today's content. There are 4 contents from comparison to application according to this. So first, what is the, how can I say, method to measure the moisture? So in the world, there are several methods to measure the moisture. The first one is Karl Fischer moisture titrator, as you know. And this is very well-known method to get a good accuracy. So the advantage is very easy to operate and short-time measurement and get high accuracy like that. But the other method, like Lawson drying method, infrared absorbing analysis method, are sometimes very difficult to measure with accurate, because sometimes it is easy to have the kind of erroneous with result. For example, in fluorinated absorbing analysis method, if there is a whole age group, so like alcohol, sometimes the result will be higher than theoretical value because of the evaporation like that. To avoid that kind of situation, if customer want to get a high accuracy, the operator want to use a Karl Fischer moisture titrator. Okay, so next slide are showing about what is Karl Fischer, about the volumetric method and colorimetric method. Speaking of the Karl Fischer, there are 2 types of the method to measure the moisture content. One is called volumetric method, and the other is called colorimetric method. And please pay attention to here. So there is a calculation formula about Karl Fischer reaction. In the Karl Fischer reagent, there is methanol, iodine, blah, 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 like this. And important thing is iodine react with H2O. So for volumetric method, there is iodine in the reagent, and we can count how much titrant we consume to get endpoint and convert it to the water content. But colorimetric method, we are checking how much electrolysis we use. That's why we call this colorimetric method. About the detail, we will explain later on. Okay, next slide showed about the kind of the characteristic of the volumetric and the colorimetric kind of the comparison. So normally, speaking of the volumetric, the target is high water content, like more than 1 milligram H2O. But on the other hand, colorimetric lower than 1 milligram H2O. This is basic information. But of course, there is irregular. Irregular means if water content is less than 1 milligram H2O, but sometimes we recommend to use volumetric Karl Fischer. It depends, because this is a very important information. I mean, sometimes by using the volumetric method, there are so many ways to get the good accuracy. But sometimes, in case using colorimetric, not so much way. I mean, to do the Karl Fischer measurement, sometimes there is a side reaction. If there is a side reaction, the result will be higher. So we have to avoid that kind of side reaction to get a precise result. For example, by changing solvent to adjust pH buffer, like that. Anyway, if the water content is lower than 1 milligram H2O, but there is no way to avoid a side reaction, in such cases, we recommend to use volumetric instead of the colorimetric method. Okay. And next is kind of the vivid information about what is the volumetric Karl Fischer. As I explained, normally the target is more than 1 milligram H2O about water content. And this is the principle of the Karl Fischer reagent. So in the volumetric Karl Fischer, there is the iodine in the Karl Fischer reagent. And then the iodine react with water and we can get the data. And this is the kind of structure. We normally prepare the Karl Fischer reagent in the burette and then connect the twin platinum electrode and checking about the potential between two pins. And in the flask, we prepare the dehydrated solvent. And then check how much is the water content. Okay, and then this is our information about volumetric. So as I explained, volumetric Karl Fischer, we have to use a titrant called KF reagent, Karl Fischer reagent. And the important thing is we have to know how much is the power of the Karl Fischer reagent per 1 ml. We normally call this a factor. So to get the precise result, we have to determine the factor at first before sample measurement, and then move to the sample measurement. And the factor will be shown as this. The unit is milligram H2O per ml. How much moisture we can erase, we can react per milliliter. After getting this kind of factor, so we can move to